Today, in this video, we will talk about the factor theorem. What is the factor theorem? Well, it states that k is a zero of f of x if and only if x minus k is a factor of f of x. So the factor theorem helps us relate the idea of a zero to factors. And this if and only if means that the direction of our arrows go both ways, as in x minus k is a factor of f of x implies that k is a zero of f of x, and k is a zero of f of x implies that x minus k is a factor of f of x. The implications go both ways. These are equivalent statements when you use an if and only if. Okay, let's look at this in concrete terms. Let's say you have some function of x equals x squared minus 7x plus 12. This is a quadratic function, and in factored form it would be x minus 3 times x minus 4. What are our zeros? Well, we find them. They would be the x values where we set f of x equal to 0 and solve for x. So here you'd have 3 being a 0, as in when you plug in 3 for x, you get f of x equaling 0, and 4 would be a 0. So since 3 is a 0, then x minus 3 is a factor of f of x. And similarly, 4 is a 0, so x minus 4 is a factor of f of x. Okay, this will relate to the remainder theorem, and also we can use synthetic division to help us find factors. So let's look at a problem from the study guide to see what I'm talking about. Okay, we want to find the following factors of this guy, this function. Okay, well, let's use synthetic division. So if it's a factor, if x plus 1 is a factor, that means negative 1 will be a 0, as in when we divide this function by x plus 1, we should get a remainder of 0 if in fact x plus 1 is a factor. Okay, so using synthetic division, and we'll see why at the end. I recommend using synthetic division, or if you'd like, you could use regular polynomial long division. Some students prefer synthetic division just because it's a more streamlined process. So you have 1 as your coefficients, negative 2, negative 19, 32, and 48. And negative 1 is a good number to start out with because it's easy to multiply negative 1, at least in these initial steps. So you have 1 dropping down, negative 1 times 1 is negative 1, negative 3. Negative 3 times negative 1 is 3, and add to get negative 16, and multiply negative 1 times negative 16 to get 16, you get 48. 48 times negative 1 is negative 48, and we get a remainder of 0. So this means, according to the remainder theorem and the factor theorem, that so negative 1 is a 0, that means x plus 1 is a factor. So why did we use synthetic division? Well, it helps us because now we have essentially factored out this x plus 1. And so x plus 1 times this quotient, which would be this guy, when we insert our variables in there, x plus 1 times our quotient will give us our dividend. And now it's going to be a little easier to use this guy instead of using this larger dividend or larger function every time to synthetically divide our options. So let's try out a few other options. Let's try out, for example, option 2, x plus 3. Let's rewrite a few things. Okay, so we're going to do x plus 3. So what should we plug in here? We should do a negative 3. And then, like I said before, we're not going to be using this. You could if you wanted to, but instead, let's use our quotient from last time. 1, negative 3, negative 16, and 48. Okay, so this 1 will drop down. 1 times negative 3 is negative 3, and negative 6. Negative 6 times negative 3 is 18. 2 times negative 3 is negative 6. 48 minus 6, well, it's not going to be 0. So it's going to be 42. So our remainder isn't 0. So by the remainder theorem, we know, well, by the factor theorem, actually, we know that x plus 3 is not a factor. X plus 1 is. So let's try a few more values out. Let's, for example, try x plus 4. And we can use these coefficients again. Okay, so negative 4. And then we have 1, negative 3, negative 16, 48. Drop down that 1, and 1 times negative 4, it's going to be negative 4, and get negative 7, and 28. 28 minus 16 is 12, times negative 4 is negative 48, and we get a remainder of 0. So when we get a remainder of 0, we know that negative 4 is a 0 of this function, and that x plus 4 by the factor theorem is a factor. So we have so far x plus 4 and x plus 1. Okay, and this quotient, when we insert our variables, becomes that guy. And this is a quadratic function that's factorable, and we factored it earlier, and we know that that factors into x minus 3 and x minus 4. Okay, so our factors, we have another factor there, and it wasn't listed, but x minus 4 is also a factor, but x plus 3 wasn't, because when we divided, we ended up getting a remainder other than 0 for this, but we got remainders of 0 for all the others, and for this one and this one in particular, and we could have synthetically divided this guy further, but since it was something that was easily factorable, we could just factor it.